So if drawing is an array of shapes, we can take a look at the shape. It has no get area in it. So we can say, well, it sounds like shape needs get area, but shape doesn't know what get area is at all. Shape could just say, well, I can promise that when you say, when you derive other classes from shape, when we say circle extends shape, rectangle extends shape, then in that case, they will provide get area and get perimeter and draw and other operations which really make sense. With shape, the trick is that we can just say that, how about this? We just copy the definition of get perimeter, right? Just copy this, right? Copy this, and copy the definition, the signature of get area as well. Just adding it to the shape. And guess what? Then the trick is that the shape doesn't really know what get perimeter is. All it knows is that this is the method that's supposed to return a floating point number, right? The type float. And therefore, the rule is, because you haven't finished, it's like this shape class is only half finished. It's really totally unfinished. Okay? So it's unfinished. It doesn't tell you anything about get perimeter or get area. It just says that we'd like to support this, but we're kind of not done just yet. Because of this half-finished business with class shape, but notice that it's very useful. It wants to be very useful class because it says if you create collections, as an example, if you create collections of shapes, they can then become very useful in getting, in providing a very uniform interface into what circles and rectangles can do. Kind of interesting trick is that beyond the point when all of the objects are created and populated, beyond this point, you can abstract away and forget which one is circle and which one is rectangle, because all of them support the same set of methods, which are convenient and expected. Get area, get perimeter, draw, multiply other things, perhaps, variety of things that they can support. And so, but because although useful, shape is only halfway finished. For this, Java requires to say it explicitly. Abstract, right? You have to make this class abstract. The abstractness of the class simply says, in reality, what it says here is that you cannot create an instance of class shape. You cannot create an object of this type. It's impossible. But what you can do is to go and derive other classes from shape, and there make sure you implement the get perimeter and get area, right? You provide the real implementation, and then you can use collections of shapes to get access to those real objects, and this becomes a very solid and effective approach to manipulate those objects during their life cycle, right? Once created, we no longer care about the actual type. Right? It could be triangle, it could be rectangle. As long as it's created, then as long as it supports the interface of class shape, they're all will be usable. So unfortunately, again, there is another piece of the rule that we have to follow, is that we need to say that those are also abstract. methods. Basically, there's a longer story. Why is this the rule? But you have to, although, you know, in my view, if something looks like, you know, a method declaration and it has no method body, only the semicolon, it should have suggests that this looks like an abstract method declaration, but Java wants you to explicitly say abstract. So hopefully now, if I save everything, so notice that since I've written circle and rectangle, I never went back after I said extends shape. I never went back and changed any of the methods. They're all just, you know, the same signature here, the same signature for both get area and perimeter, right? And everything is just in good shape, really, right? So then we did those a few tricks here to make sure that we can use shape to access get perimeter and get area of a real thing, such as circle and rectangle, and we try to make a good use of it in our main method right here. So if we run it, hopefully it'll print the number if it compiles. So my area is 706.85 square units, right? I don't know what those units are expressed as floating point numbers, but that's the area so far that I was able to do. So it works and it's effective. And so I can use this in my designs, and I can use it in my, you know, in my application. Yes, question?
I have an error in my program. It says the rectangle is not abstract in my rectangle class.
Oh, it's because what happens is that you must be missing something in. Do you have get perimeter and do you have get area?
Yeah.
Do they both look like this and don't have semicolons?
No.
There are no semicolons. And do you have extends?
No.
Extends shape. So your rectangle extends shape. You have that. Okay. And so it says not abstract. Typically, it would be an error if you didn't have get perimeter or get area. You make sure that you spell everything correctly. How about this? Try this. Say override.
I found it, the height and flow things were applied that we changed it.
Oh, okay. So you changed that? Yeah. So typically, to make sure that it's kind of like it sounds like a really good idea oftentimes to make sure that what we do here is exactly what we do over here, and to make sure that compiler actually makes a check is that you can use this annotation named override. It's a good practice, and it's very useful, sort of like annotation to our methods, in case if we know our intent here is to make sure that we implement a particular method, which means that we override our method, which was perhaps previously defined, and so we provide this real implementation. Override really helps. I really like this annotation, and so in both of my classes I can definitely add those two annotations. All right. So anyway, let's save everything and let's make sure it's runnable. So if I run this again, so it says 706.8, and it obviously rounds the number during the output, but we get this this result, right? So we get this result. It's very helpful. I would say this code is kind of effective and makes a pretty good, pretty good intent of using classes, and then also is very effectively calculating the area, right? Produces the result and prints the result. So if everything kind of sticks together. And I showed you my sort of like adventure into this application by starting with like the main method, trying to create these objects, try to maintain a list or array of these objects, and then making sure that I can get my classes to behave exactly as intended. So this is our first look at the inheritance. So we still have to, we probably should take a break now, maybe 5 or 10 minutes break. And after the break, we should go back and explain maybe, or revisit again, the UML aspect of it, what the UML diagram of this application might look like, and also just say a few more things about the inheritance. So let's take a break, 5-10 minutes.